Okay, in the last section of Unit 5, talk about reflections and symmetry. We're going to identify and use reflections and lines of symmetry. So the first thing we need to do is define a reflection. Reflection is creating a mirror image. It's a transformation. The original line is reflected in a line that's called the line of reflection. So in this example, the beginning here, your line of reflection is basically right in the middle of the two images. It's the perpendicular bisector of the segments that join two corresponding parts. So the blue will be the original image, and the red will be the reflected or try to be reflected image. So we have the pre-image, which is the original, and the image, which is after the transformation. So first thing we do here is we look. We would draw a line connecting the points. Is line M the perpendicular bisector? And it is. So that's one question you ask. And that's yes. The other is the image congruent and that's a yes. They're the same size, same shape. And is a reflected image reversed? And yes. So this would be yes to the original question. So when I look at this one, it's not a reversed image to begin with, so this is going to be no. Okay, we're going to look at the blue is the original, and which one is reflected across the x-axis. So the x-axis, so I want to go across that. The only one that can be would be JK. And which point corresponds to A, J prime, and which point corresponds to B, K. I guess that's not a prime, sorry, it's just a J. Okay, and B we're looking for the Y. Which one's reflected across the Y? And we have ED. What corresponds to A is D and B is E. So you go ahead and try these. Just determine whether or not it's a reflection, if it is, what the line of reflection is. Symmetry. This is a guy standing at the end of a mirror. The mirror's edge is that line of symmetry. It's where the figure can be reflected onto itself by this reflection line. So how many lines of symmetry can we draw? So I can draw one right down the middle here. So I fold it in half. One half will be the same as the other. And I can put a line there, and it would split in half. So this has 2. B would not have any. There's nowhere you can draw a line that one side will be the same as the other. And then this figure can go through each of the vertices, and then halfway between. In using these, think of a kaleidoscope. We can have an angle of symmetry that's found. Excuse me, and it's found by taking 180, that's just part of the formula, divided by the number of lines of symmetry. So in A, it's 180 divided by 3 lines of symmetry. So the angle would be 60. 180 divided by 1, 2, 3, 4. 180 1, 2, 3, 4, 5, 6. Okay, so determine how many lines of symmetry we have in each of the figures. So how is a figure similar to and different from its reflected image? Okay, they're similar because they're congruent. And they're different because they're reversed. And the assignment follows.